Hello everyone. So today we'll discuss IUPAC of organic compound, where that we will study that all those rules given by IUPAC for defining the name of organic compound, and we will discuss some example also so that properly we can understand all those rules. So first we will discuss that what is organic compound. So organic compounds are hydrocarbon and hydrocarbon derivatives. So hydrocarbon means when carbon and hydrogen is present, that is called hydrocarbon. Along with carbon and hydrogen, if other atoms like oxygen, nitrogen, halogen, sulfur, phosphorus is present, then that is called hydrocarbon derivatives. And both hydrocarbon and hydrocarbon derivatives are organic compound. Suppose for example CH4 methane or CH3OH, this is derivative of hydrocarbon. Both are organic compound. One scientist whose name was Berzelius, so he gave one vital force theory. According to that theory, he told or he claimed that all those organic compound only can be derived through living force, means which having consciousness. But Huller was one scientist who did experiment that with ammonium sulfate and potassium cyanide, and accidentally first organic compound is synthesized in laboratory by Huller. So here you can see that by this reaction, double displacement reaction, ammonium cyanide and potassium sulfate is formed. So when he was doing test of all cations and anions, right side, so he got that test of potassium, he got the test of sulfate ion, but he was not getting the test of ammonium cyanide. So after repeated experiment, then after he came to conclusion that this compound is rearranged, and this rearranged compound is only first synthesized organic compound, that is urea. So this both are isomer of each other, since their molecular formula is same, only their structure is different, and this by this that vital force theory was disregarded. Now we will discuss that du double, that degree of unsaturation, or this is also called HDI, hydrogen deficiency index, or also in question it will be mentioned DBE, double bond equivalent. So what is meaning of that double bond equivalent? 1 mole of unsaturated hydrocarbon, from that in that if we are adding n mole of H2, and by that if it is becoming 1 mole of saturated hydrocarbon, then it is called its degree of unsaturation is N. Or vice versa, if 1 mole of saturated open saturated hydrocarbon is there, from that n moles of H2 if it is removed, due to that if it is becoming 1 mole of unsaturated hydrocarbon, unsaturated means alkene or alkyne or cyclic system, then that N is called its degree of unsaturation. If suppose for example if a structure is given, then for that degree of unsaturation will be number of pi bond plus total ring. For molecular formula, if it is given for organic compound, its du will be total number of carbon plus 1 minus monovalent minus trivalent divided by 2. Monovalent here hydrogen, deuterium or tritium, and halogens fluorine, chlorine, bromine, iodine, minus trivalent divided by 2. Divalent oxygen and sulfur we will ignore. So like here you can see in this molecular formula, here it is given C6H11NO. So carbon 6 plus 1 7 minus monovalent how many? Hydrogen 11 minus trivalent 1 divided by 2. So it is 10 divided by 2 5. So total degree of unsaturation is 2. Means in this hydrocarbon, if we'll add 2 moles of H2, then it will become open saturated hydrocarbon chain, and that's why its degree of unsaturation is 2. Similarly here that organic compound is given, so in that again carbon 8 plus 1, here it is 9 minus monovalent total 8 divided by 2. So its degree of unsaturation is 5. Similarly here you can see that this is one cycle, so its degree of unsaturation is 1, triple, that how many double bonds are there? 3 double bonds are there. So its degree of unsaturation here 3. And in aldehyde also carbon double bond oxygen. So total number of pi bonds how many? 4 plus ring 1. So total degree of unsaturation is 5. Here you can see that total number of ring plus pi bond is 0. So ring, if we'll see that total faces are 6 faces. So its degree of unsaturation, it seems like that it should be 6. But no, degree of unsaturation is 5. Means if we'll open its 5 faces, then it will become open saturated hydrocarbon. No need to open another last 6th one. So its degree of unsaturation is 5 only instead of 6. Here also you can see it having 5 faces. So it's expected that its degree of unsaturation should be 5, but degree of unsaturation is 4 only. Why? Because if you open 4 surfaces, it will become open saturated hydrocarbon. So from here, don't derive any preconceived notion that whenever such type of a structure is given, means degree of unsaturation total number of phase minus 1. No, whenever such type of a structure is given, you try to open it by giving n moles of H2, and if it is becoming open saturated hydrocarbon, that is only its degree of unsaturation. So don't derive any notion by this example. Next, moving, we will discuss that degree of carbon and hydrogen. So degree of carbon and hydrogen, how to define? That 1 degree carbon means that carbon is associated with another 1 carbon. If it is 2 degree carbon means that carbon is associated with another 2 degree carbon. 3 degree carbon means that carbon is associated with another 3 other carbons. 4 degree carbon means that carbon is associated with another 4 carbons. And hydrogen, whatever is present on that respective degrees, is called its degree of hydrogen. But remember, 4 degree hydrogen do not exist because carbon is tetravalent. So here that you can see this carbon is associated with 2 another carbon, so it is 2 degree carbon. On that this hydrogen is present, so this is called 2 degree hydrogen. So like that remaining also you can calculate. Next, moving further, degree of alcohol. So degree of alcohol defined through degree of carbon only. If OH group is present on 1 degree carbon, then it is called 1 degree alcohol. If it is present on 2 degree carbon, 2 degree alcohol. If it is present on 3 degree carbon, then 3 degree alcohol. 4 degree alcohol do not exist. All 1 degree, 2 degree, 3 degree alcohols are same functional group, means their chemical properties will be same. POH means phenol is not alcohol. This is different functional group altogether. Next, coming to amines. So in amines, that you know that amine, that nitrogen, this will be connected to main chain. Here that hydrogen, deuterium or tritium, any or both, if both is hydrogen or both is deuterium or hydrogen deuterium. Understood? So that is called 1 degree amine. If one hydrogen and this side carbon is there, then it is called 2 degree amine. If both this one is 0 hydrogen, then it's called 3 degree amine. All 1 degree, 2 degree, 3 degree amines are different functional group, means their chemical properties will be different. Next, degree of amide. So degree of amide, you know amide is derivatives of carboxylic acid. So here C double bond ON, this will be to fix. But here if 2 hydrogen is there or hydrogen deuterium is there, then it is 1 degree amide. If hydrogen and alkyl group is there, means one hydrogen is here, you can see removed by carbon, so it is called 2 degree. And both side if carbon and connected to main chain, then it is called 3 degree amide. All 1 degree, 2 degree, 3 degree amide, like 1 degree, 2 degree amines is a different functional group. Next, moving for halogens. So halogens degree is defined through degree of carbons, same like alcohol. 4 degree halogen do not exist. Dihalide means 2 halogens group. If 2 halogens group present at 1 carbon only, then it is called geminal, gem dihalide. If it is present on adjacent carbon, then it is called vic or vicinal dihalide. But if it is present After this is 1 2. If it is present at 1 3, 1 4, 1 5 and so on and so forth, then it is called isolated dihalides. Remember, fluorine, chlorine, bromine, all are considered different functional group. Next, moving homologous series. So homologous series means those series which having same that functional group, same general formula, same chemical properties, because chemical property derived only through functional group. Next, two consecutive member means adjacent members is differ by only CH2 or 14 AMU, and their physical properties are in regular gradation increases, like here methanol, propanol, methanol, ethanol, propanol, 1 carbon increasing, so van der Waal interaction increasing, so what boiling point also subsequently it will increase. Here you can see that one example, that which of followings are here belongs to, is this all those three compounds belong to homologous series? Yes, it belongs to homologous series. Why? Because their functional group is same, OH OH. You know, 1 degree, 2 degree, 3 degree alcohols are same functional group, and along with that its general formula is also same. Yes, these two are not adjacent member, but they belongs to same series which having general formula CnH2n plus 1 OH, means it is homologous series. Is that clear? So in that, if it will be adjacent, then it is well and good, means all properties will be followed. Even though if it is not there, but this belongs to same series only, so yes, it is homologous series. Next, organic compound classification. That organic compound classified, you can see one is open or aliphatic compound and one is cyclic or closed chain. So open chains are two types, saturated and unsaturated. Saturateds are alkanes, unsaturateds are alkene and alkyne. Closed chain is again two type, one is homocyclic and one is heterocyclic. Homocyclic means in that all that cycle will be formed by carbon atoms. Heterocyclic in that at least one atom will be different than carbon, and it is heterocyclic, you can see. So homo and heterocyclic again classified into alicyclic and aromatic compound. So alicyclic means which is non-aromatic, and aromatic compound means which follow, it must be cyclic, it must be planar, it must follow Huckel rule, 4n plus 2 pi electron. So in that you can see this is, all those are having 4n plus 2 pi electron. Whereas heterocyclic, in that also alicyclic and aromatic heterocyclic compounds are there. In that you can see this is also following Huckel rule, cyclic and planar. In aromatic compound, two different types of compounds there. One is which is derived from benzene ring and which is not derived from benzene ring. So here you can see this is benzene, this is also derived from benzene ring. So naphthalene, similarly anthracene, phenanthrene. Whereas non-benzenoid ring, like here you can see aniline 18. So in isomerism we will discuss all those aniline 16, aniline 10, this all those. In GOC in fact also we will study. So this is, you can see, aromatic compound and it having 18 pi electron. It is cyclic and planar but not derived from benzene ring. Hence this is also aromatic compound, one classification, non-benzenoid aromatic compounds. Clear? Next, moving further, now we will discuss that all those rules given by IUPAC. So first here you can see that in old system that all alkanes are considered as paraffins, which is inert, because in that pi bond is not there, so they are not that reactive, so they are considered as inert. Alkenes is considered as olefins and alkynes is considered as acetylenes. So here that all those rules given by IUPAC, this all those rules we will apply in sequence while giving name of any organic compound. So first select the longest carbon chain. So that longest carbon chain means maximum number of carbon must be there if it is saturated. So this is, you can see, it is called principal chain or main chain. This all those you know, and this is side chain, locant or branch chain. If main chain is more than one possible, then select that main chain which having higher number of side chains. Like here you can see this is one main chain, another main chain, this one is also possible. So in that this main chain having two branches, but if we will take this one as a main chain, this one as a main chain, so it having only one branch. So select that main chain which having more number of branching. Then while writing naming, what will be sequence? So first we will write prefix 2 degree, then after prefix 1 degree, after that word root, then after suffix 1 degree and suffix 2 degree. You know that word root is what? That in main chain whatever the number of carbon present, that is called its word root. For one carbon it is called meth, then after for two carbon eth, prop, but, pent, hex, hept, oct, non, dec. For 11 undec. Understood? Similarly dodec, tridec. Similarly for 19 it is called nonadec, and for 20 iquos. And 1 degree suffix is what? That for alkene, if it is alkene main chain system, then N will come. If alkene, alkene if it is there, double bond system, then in will come in the suffix 1 degree. If it is alkyne, then suffix will be 1 degree will be ine. And suffix 2 degree defined for functional group which is as a main functional group. And remaining functional groups, suppose in that main chain more than one functional groups are there, so one functional group will be as per priority which is given by IUPAC will be main functional group. Remaining all functional group will be in prefix 2 degree. And prefix 1 degree is what? That all those, like suppose this is the main chain, so in that here it is methyl is coming, here ethyl is coming, so this all those alkyls will be in prefix 1 degree. Clear? So prefix 2 degree for remaining all functional group, prefix 1 degree for all alkyl groups, word root means meth, eth, like that. This suffix 1 degree for alkene, alkyne means alkane, alkene, alkyne, and suffix 2 degree for main functional group. Clear? So this 3 rule we discussed. Select longest carbon chain. If more than one longest carbon chain, then select which having more number of branching. Then third, how to write its general formula. Next we will do, for writing its IUPAC naming, we need to do numbering also. So that if locant is there, locant must get lowest possible number. If more than one locant is there, then always follow lowest sum rule. Like here you can see in this only, that if I am doing numbering, so I can do numbering from this side also and from this side also. So from this side it will come 2, 3, but from this side if we'll do, it will come 5 and 6. So 2 and 3 is the lowest sum rule. So we'll do numbering from this side. So 2 methyl is coming and 3 ethyl is coming. So while writing, we will write ethyl alphabetically senior first, then after we will write methyl, and then after we will write heptane. Clear? Means 3 ethyl, 2 methyl, heptane. So here this rule also what telling, if one locant is there, then try to get lowest possible number. If more than one locant is there, then follow the lowest sum rule. If lowest sum rule is coming same from both sides, then you go by alphabetical order. Understood? If alphabetical order is not valid, then you follow lowest sum rule only, but while writing that, first you write alphabetically senior atoms, like we wrote 3 ethyl, 2 methyl, heptane. So once again, if one locant is there, then you give lowest number. If more than one locant is there, then apply lowest sum rule. If that lowest sum rule is same, then you go by alphabetical order. If alphabetical order is null and void, then you follow this lowest sum rule only. But while writing, always you give priority for writing the alphabetically senior that alkyl group. Next, multiple same prefix. For that you can use, if two multiple that prefix is there, di. If it is 3, tri. If it is 4, tetra. Remember, while writing IUPAC naming, if E is coming, and after that A, E, I, O, U is coming, so E you can ignore. We will study also. So whenever that while writing IUPAC naming, in that if E is coming, like suppose for example alkene system is there and along with that carboxylic acid is also there. So in alkene E is there and oic acid in that O is coming, so that in alkene E we will cancel. So E will be ignored if after that A, I, O, U is coming. Next, here this all those rules we will apply in sequence. Already we studied in classes. Next, complex substituent. Complex substituent means those organic compounds which having branch. So like here you can see this is the main chain and this is the branch chain. In branch also having branch. So always remember, if branch having branch, always this carbon is always giving will be given name as a, means numbering will be given as a 1. So this is 1 dash and this is 2 dash. Even here if any functional group also associated, always this carbon we will give as a 1 dash, then after 2 dash and so forth. That 1 dash you can see this is methyl group. So 3, because it is connected to 3, so 3 1 dash methyl ethyl bracket close, then after hexane, or we can also write 3 isopropyl, this is isopropyl group hexane. Clear? For multiple such type of, if such type of branches if it is coming, so for 2 bis, for 3 tris, for 4 tetrakis, for 5 pentakis, and so on and so forth. Next, cycloalkane. So for cycloalkane, again same like that order we will follow. Prefix will be, then cyclo, only word will be additionally added, word root, suffix 1 degree means for alkane, alkyne, suffix 2 degree for functional group. Like here you can see that this is isopropyl, 1 isopropyl cyclopropane. But if carbon is here, carbon is 3, here also carbon is 3. So in that we will consider this cycle only as a main chain. But if open chain here, if it is more than cyclic carbon, then open chain is considered as main chain and this is considered as alkyl group. So here you can see 2 cyclopropyl butane. Next, moving further, for alkene. For alkene, always while considering main chain, our maximum possibility should be to include all alkene system in that main chain. Suffix you know that in we will add. Numbering to provide lowest number for alkene system. Means for alkene system in that main chain we will provide lowest number. Then after we will take care of that all those locants, lowest sum rule, alphabetical orders, and that all those. So, and if more than one alkene system is there in main chain, then you add A in the word root. Like eth is there, so it will be eth, etha. Etha to not possible, but if it is but is there, so we will write buta. Buta 1,3 diene. Clear? So here you can see some examples like here. So first what will be main chain? Main chain will be this one, not this one. Include maximum number of double bond irrespective of longest carbon chain. If longest carbon chain also possible while including all maximum double bond, then it is well and good. If it is not there, then always you try to include maximum number of double bond even that carbon chain length is shorter. So here you can see this is the main chain, and while giving numbering, if we'll do here 1 2, so at 2 ethyl is coming. From this side if we'll do, it is coming 3, so lowest we will follow. Means point is that from this side 1 2 3 4, and from this side if we'll do 1 2 3 4. So see, first we will give priority to alkene. So alkene here it is getting 1 and here alkene is getting 3. From this side alkene is getting 1 and this one is getting 3. So if alkene is sorted, then we will consider for locant. So for locant, here you can see locant, here it is coming this side if we are doing 2, and from this side if we'll do, it is coming 3. So better we will go by lowest rule for locant also, along with lowest sum rule for main chain. So here it is 2 methyl 3 propyl buta, A is coming along with 1,3 diene. Similarly here, irrespective of longest carbon chain, this open chain only will be our main chain. Similarly here, this is our main chain. So first we will give priority to our double bond. So here you can see 1 3 is coming, but from this side if we'll do, it will be 1, then after 1 2. So double bond here it is coming, minimum position is 2, and then after 3 4. So 2 4 is coming, but from this side it is 1 and 3. So first we will keep priority while giving numbering to double bond, and then after if possible we will take care of locate. Like here we discuss here that double bond from both sides is coming same, then locant be considered. If double bond is only getting disturbed, then locant will not give priority while giving numbering. So here it is 4 methyl penta 1,3 diene. Same this rule we will replicate for alkyne system also. Chain must include maximum number of alkyne. This is not alkene. Maximum number of alkyne must be there along with in that main chain. Along with that, suffix must be ine. Numbering must be provided lowest number to all alkyne system. A will be added if multiple double triple bond is there. So like here you can see that it is penta 1,3 diene. So here not double bond, it will be triple bond. Okay, next moving further, this example you can see this is double bond and triple bond. So if double bond and triple bond is there, so while giving numbering, first we will give priority for first lowest sum rule. If it is valid from both sides, then we will give priority to double bond only as compared to triple bond. So here this is 1 2 3 4 5. So hex 1 in 4 ine. From this side you can see 1 2 3 4 5. So here first we will follow lowest sum rule rather than if we will go by this way. So here it is coming 2 and then after here it is coming 4. But from this side 2 4 means 6. But from this side 1 2 3 4 5. So 1 3 means lowest sum rule is valid from this side. So lowest sum rule we will consider, and while writing we will consider double bond as a priority. So here you can see alkene 3 in and 1 ine is coming. So here after E Y is coming, so this E1 cancelled. Clear? Similarly here also if after E A I O Y is coming, then E will be cancelled. Next coming to cycloalkene or alkyne. So cycloalkene alkyne, like here this example. So in this again lowest sum rule. So here you can see that only alkyne system is there. So normal cyclounidecyne. You can do this naming by yourself also. Next coming to complex. So complex, in that if double bond is directly connected to main chain, means this double bond contribution 50% to main chain also, 50% with side chain also. In that suffix we will add idene. So here you can see 1 2 3 4 5. So at 5 what is there? Ethyl idene, 2 carbon. So ethyl idene, cyclo hexa 1,3 diene. Similarly here also this is the main chain, longest carbon chain also included maximum number of double bond. So this will be our branch chain, but this double bond is not connected directly to main chain. So here idene we will not consider. So it will be 3 eth and then after in. So in that E cancelled due to Y because it is overall alkyl group. So 3 ethinyl hexa 1,5 diene. While selecting main chain, now first we will give priority to functional group. Even longest carbon chain is valid or not, we are getting, even we are getting or not getting, no problem. But first we will try to get that functional group in our main chain. Second, priority is that alkene and alkyne. In alkene alkyne also alkene will be first priority. Then after longest carbon chain and longest carbon chain which having more number of side chains. Understood? So like that, this is the priority. Once again, functional group, then after alkene, alkynes, then after longest chain. If longest chain from both side, if it is coming same, then that chain which having more number of side chains. Here already we discussed this one, priority order for numbering. First we'll give priority for numbering while parent chain if it is having alkene alkyne system or functional group. Then after we will consider for locant. Like here, that first we will consider this one for double bond as a numbering is coming 1 and 3, rather than we will do numbering from this side. Understood? If we will do numbering from this side, then it will come 1 comma 3. But from this side it is coming 1 comma 3. Oh, from this side both side it is coming same only. So instead of that we'll give numbering this one 1 2 3 4. Understood? So not this one, we'll write here this one 1, then after 2 3 and 4, because from both side it is coming same only for double bond 1 and 3. So if it is coming same, then we will give priority to locant also. Then it is 2 methyl, and along with that, no, I am sorry, here actually this one also is locant, no. So here locant is 3 comma 2 comma 3, 2 comma 3, but here that, and from this side also 2 comma 3. So better we will give, this is alphabetically senior, so we'll give this one as a priority. Then it is correct only. Then we will do 2 ethyl, 3 methyl and buta 1 comma 3 diene. Okay, next priority order we will study. So priority order, this all those you should remember, this priority order of functional group. This is priority order also, along with that prefix and suffix also. If functional group is considered as a main functional group, then we will consider its suffix as a 2 degree. If functional group is present as a prefix, then its prefix 2 degree also is there. So memorize this all those, like for carboxylic acid, carboxy, and suffix will be oic acid when carbon is not included. And if carbon is included, if carbon is included in main chain, then it will be oic acid. If carbon is not included in main chain, then it will be carboxylic acid. Similarly, this is the sulfo prefix and sulfonic acid. Here, since it is not carbon is there in that functional group, so include and exclude is not possible in main chain. Next here, carboxylic acid derivative anhydride. So for this prefix not possible, but yes, suffix is there, oic anhydride when carbon is included. When carbon is excluded, then carboxylic anhydride. Similarly here, this is ether. So for not ether, this is ester. So for ester, this is O8 when carbon is not included, carbon is included, and carboxylate when carbon is not included. And prefix will be alkoxycarbonyl or alkanoyl oxy. We will see examples. Similarly here acid halide. So for acid halide, prefix will be halocarbonyl or oil halide when carbon is included. If carbon is not included, carbonyl halide. Similarly here you can see for amide, this is also carboxylic acid derivative. So for this prefix will be carb amyl and suffix will be amide or carboxamide. And for cyanide, cyano, and if carbon is included, nitrile. If carbon is not included in main chain, carbonitrile. Similarly isocyanide. So isocyanide prefix will be isocyanide, carb amyl is as a suffix 2 degree. For this aldehyde, if carbon is included in main chain, otherwise carbaldehyde, and prefix will be formyl or oxo. For ketone, on or keto or oxo. Clear? This all those we discuss in detail each functional group in classes. Next, here this OH is functional group, alcohol. So for that OL as a suffix, hydroxy as a prefix. Similarly, thiol is a for SH and mercapto as a prefix. Similarly, NH2, amine as a suffix, amino it is its prefix. Similarly, OR. So for OR, this is for that ether. Ether is never considered in that as a primary that suffix or primary functional group. Always it will be in prefix, and it is alkoxy. Double bond, triple bond also after functional group, you know, double bond and triple bond will be given priority. So like that. Here this all those are there like halogens. So these all those halogens are also considered as functional group. Nitro, nitroso, nitrito, alkyl, methoxy, phenyl, phenoxy. These all those in that this all those are functional group, but this functional group always present in prefix. They never come in suffix. So no suffix for them while writing. Just we need to take care of their alphabetical orders. So moving further, here you can see some additional also, like this is same ether only, cyclic ether, it is called epoxy. This is also present in prefix only, like this. Azide, you know, nitrogen, 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 N3 minus 1. Carbon double bond nitrogen, and both side here carbon and this side one carbon and this one lone pair, then it is called imine. If carbon double bond nitrogen but along with that OH system is there, then it is called oxime. And carbon double bond in between nitrogen is there, then it is called imide. Thiol already you know. Like here we discuss ether, like that this is thioether. And this is carbon double bond nitrogen double bond nitrogen, this is called diazo group. Understood? Whenever AZ word is coming means nitrogen bond will be there, nitrogen bond. Moving further, next we will do some practice. So that here you can see in this, if that in main chain, this is our main chain, in that main chain if one functional group, carboxylic group, if it is not connected directly to the main chain, then always you will follow the old IUPAC naming. Old IUPAC naming means that this is the main chain, in that this one is a prefix. So this will be 3 carboxy methyl pentane 1,5 dioic acid. But if all functional group carboxylic acid connected directly attached to the main chain, then we will consider its new IUPAC naming system. What is that? You can see this is the main chain, with that directly carboxylic acid is connected. Then we will consider this one as a main chain. So it is pentane. In that you can see that double bond is there at 3. So pent 3 in 1, 1, 2, 5 tetra carboxylic acid. Clear? Here C is coming carboxylic acid, so this E will be not cancelled. Some important carboxylic acid you remember directly they will ask, like lactic acid. So this is the lactic acid, its general, this is its common name, this is its IUPAC name. So you can see this is the main functional group, so this will be as a prefix 2 degree, so 2 hydroxypropanoic acid. Similarly this is pyruvic acid, so in pyruvic acid again this ketone as a secondary prefix, so 2-oxopropanoic acid. Similarly this is malic acid, so in this again 1, 2, 3, 4, so at 2 hydroxy. This is cinnamic acid, very important, 3-phenyl prop 2 enoic acid. This is citric acid, 2 hydroxy propane 1, 2, 3 carboxylic acid. New IUPAC rule directly attached to the main chain 1, 2, 3. Next, for dicarboxylic acid, Ohm's gap. O means oxalic, M means malic, S means succinic, G means glutaric, A means adipic, P means pymalic. So these all those are dicarboxylic acid. Oxalic acid, in that between two carboxylic acid, 0 carbon will be there. In malonic acid, between two carboxylic acid, 1 carbon. Here between two carbon. Here 3 carbon. Here 4 carbon. Here 5 carbon. Clear? This is fumaric acid, like trans, and this is the malic acid. So 3 we discuss. One is that here you can see this one is malic acid, whereas this one is MALE. So this malic acid is different, and this is malonic acid. Next, moving further, here you can see that this one is the our main chain, which having that directly attached this two functional group, but one is not directly attached. So what we will write? We'll write again, always we'll start one from here for branch chain. So 1 2 3. So at 3 what is there? Oxo. So 3-oxopropyl, and then after where it is connected at 4th position. So 4,3-oxopropyl, cyclohexane, 1,2 dicarbaldehyde. Or also we can consider, if I am considering this one as a formyl, then it will be ethyl only. So 2-formyl, ethyl, cyclohexane, 1,2 dicarbaldehyde. Clear? Here now anhydride. So from acid, if we'll remove water, it will become acid anhydride, means anhydride, derivative of acid. So here you can see this is symmetrical anhydride. So here only you write one part, ethanoic anhydride. But if it is unsymmetrical, you have to write both with alphabetical order, ethanoic, propanoic anhydride. Such type of anhydride, for that what you can do, you just put water, open this one, and then after write like a acid, but just remove acid and write anhydride, since it is derivative of acid. So cyclohexane, 1,2 dicarboxylic anhydride. If we'll open this one, so it will be 1,2. Here if we'll open, so this is not cycle, so this is again 1 2 3. So here if we'll give naming, so it will be bromine also will be lowest number, and alkene also will be lowest number. So we'll write from this side. So 1 2 3 4. So 2 bromo, 3 methyl, but here in that E cancelled, 1,4 dioic acid, because O is coming after E, and acid no anhydride. Clear? Next, moving further, here we will discuss that IUPAC naming of all those that ester. So here for ester, what is alkyl alkanoate? So here you can see this portion is alkyl, and this one is alkyl, and this side this one is alkanoate. So here this one is alkyl, in that this one is a branch. So 1 ethyl propyl, and then after alkanoate means methanoate. Similarly here this is methyl. So only one methyl you write, and then after this is propane, 1, 2, 3, and 2 double bond system along with here that double bond, C double bond O, C double bond O. So methyl propane dioate. So for ester, what is alkyl alkanoate is the naming. But if it is coming as a prefix, then how to write? So we discuss, either we will write alkanoyl oxy or alkoxy carbonyl. So here you can see, if this is the carboxylic acid, so this is the main functional group. So here that ester became as a secondary, means it will come as a prefix. Similarly here also it is coming as a prefix. So if it is coming as a prefix, then there is two possibility. Either it will be oxygen directly connected or carbonyl is connected. So if it is oxygen is connected, then from here you can see this one is main chain. So we'll start numbering from here to 1 2 3. So from 3 this one is connected. So we'll write alkanoyl oxy. So this is alkanoyl, this one is alkanoyl. So alkanoyl is what? Ethanoyl, and along with that since carbon is already included. So this is oxy. So 3-ethanoyl oxypropanoic acid. Or another is what possible, that alkoxy carbonyl. So if it is carbonyl is connected, then here we will write methoxy. This is the methoxy. Not sorry, this one as a methoxy, and along with that this is the carbonyl. If here it is another one carbon, then it will be ethoxy along with that carbonyl. So this is alkoxy carbonyl, methoxy carbonyl, propanoic acid. Clear? Next, so we discuss that ester as a, if it is behaving as a main chain, then it will be alkyl alkanoate. But when it is behaving as a prefix, means if another functional group is there, then it will behave, if oxygen is there, then it will behave as a alkanoyl oxy or alkoxy carbonyl along with that main chain with main functional group. Next, now after ester, here it is ether. So ether always will come as a prefix only. For this writing naming, alkoxy alkane. Alkoxy, which one will be alkoxy? Which one is smaller in size? Like here you can see ethoxy propane. Here also you can see propoxy cyclobutane. Clear? Next we will discuss bicyclo compound. So bicyclo compound means two homocyclic will be there and two common carbon in that bicyclo compounds, two common carbon. While doing numbering, always you will start from bridgehead, means that common carbon bridgehead center, and numbering will be followed by, first it will move from largest path to the smallest path, and then after that largest path to the smaller path, then after the smallest path. So here you can see this is the largest path, then after this one is with respect to this two carbon, then after this one is the smaller path, chota rasta, and this is the sabse chota laghu rasta. Means first we will do numbering of largest, then after larger, then after smaller. While writing naming, what we will do, prefix always will write, but here one will come bicyclo, x comma y comma z, word root same like that, suffix also same like that, suffix 2 degree also same. X, Y, Z is just telling number of carbon with respect to this two carbon. So here how many carbons are there? 4. Here how many? 3. Here with respect to the 2, another how many carbon? 0. So X, Y, Z is just telling its value. So this one. So here we can see that this is bicyclo compound, in that this side and this side both length is same only. So anyway we can do numbering. Always numbering must start from bridgehead followed by largest path, then larger, then a smaller. But here larger and largest both are same. So we'll start from here, but since here carboxylic acid is there, so we'll go this side. So 1, 2, 3, 4, 5, 6, and then after this one will be 7. So this is 3 hydroxy bicyclo. How many carbon here? 2 carbon. How many carbon here? 2 carbon. Here how many carbon? 2 carbon with respect to this 2 bridgehead. So 2 comma 2 comma 1 heptane 2 carboxylic acid. Similarly here also. So this is the numbering will start from bridgehead. Since this side double bond, so numbering will follow this way. So largest path 1, 2, 3, 4 like that. So bicyclo, how many carbon? Here 4. Here how many? 2. Here how many? 1. So 4 comma 2 comma 1. Non 3-ene carb aldehyde. Clear? 2 carb aldehyde. So 2 carb aldehyde means here we need to add carb aldehyde also. CHO. Okay. Next, moving further. Aspiro compound. Aspiro compound means again it is also 2 homocyclic, in that 1 common carbon will be there irrespective of that. In bicyclo 2 carbon, here it will be 1 carbon. Numbering we will start from a smaller to larger ring, and always number will start from adjacent carbon of the common carbon. Like let's suppose this is the common carbon, numbering will start from here, will followed by lower, that smaller path to higher path, means longest path. Prefix same like that, bicyclo, aspiro, here it will be x comma y only, word root, suffix primary and secondary. So here you can see that 2 carbon, here how many carbon? 4 carbon. So aspiro, sorry, with respect to this, how many here carbon? 3 carbon. So aspiro 3 comma 4 octane. Similarly here also numbering will start from adjacent of that common carbon followed by a smaller path, even though any functional group is there. So 1 2 3 4, yes, from 4 we will go this way so that we can give a smaller number at least. So 4 5 6 7 8. So it is coming 7 phenyl aspiro 3 comma 4 oct 6 on, E will be cancelled since here it is O. Similarly you can define this one also. So aspiro numbering will start from here, correct? Huh? To 1 2 3 4 5 6 7 like that. So here aspiro 3 comma 3 heptane 1 comma 2 dicarboxylic anhydride. And this is already we discussed ether. Ether is cyclic ether. It is heterocyclic, means oxygen is there in cycle. At least one will be that in cycle, not carbon, other atoms will be there. Then it is called heterocyclic, and always in prefix. So how to do this prefix name? Like here you can see 1 2. So 1 2 epoxy propane. Here 1, then after 2 3 4 5 6. So it is 1 comma 6 epoxy cyclohexane. Here 1 2 3 4 5 6 7. So 2 comma 6 epoxy heptane. Clear? Now some common name we will see. That common means alkyl group. Like here, this is normal, means simple chain, no branching. So it is called normal pentane. If it is branching and if that is coming at 2 degree carbon, then iso word will become. So this is isopentane. If it is that this carbon, if it is 4 degree and this type of system is there, then it is called neopentane. If that hydrogen is removed from 2 degree carbon, then it is called secondary butyl. If hydrogen is removed from 3 degree carbon, then it is called tert butyl. Similarly, if hydrogen is removed from normal that linear chain, then it is called normal butyl. Means alkyl word is coming on, means from alkane one hydrogen is removed. Similarly, if hydrogen is removed from here, then it is called neopentyl. But if hydrogen is removed from here, then it is called tert pentyl. Difference between neo and tert. Here this structure you need to remember. There is no any clue. This you need to remember only. Isooctane, this is the isooctane structure. Isobutane, this is the structure. This is benzene, but here no benzene. So this is benzene hexachloride, whereas this one hexachlorobenzene. So this 4 structure memorize. Moving further, next after that, this aromatic compound, some compounds, special compounds, that naming, like this is called benzene. This is not called cyclohexa 1 3 5 triene. This is not alkene, because here this all those pi bonds are delocalized. So here we will write benzene only, will not write cyclohexa 1 3 5 triene. This is phenoxybenzene. This is also called phenetol. Similarly, this is toluene. This is cumene or isopropyl benzene. This is orthogylene, metaparagylene also, you know. This is cyanide group. So this is benzene carbonitrile, because this carbon is not included in the main chain, or benzonitrile also. So whenever remember, if that carbon, this carbon, all 3 hydrogen is utilized in valency, then word in that benzo will come. We'll study in this only, in this segment. Next, here you can see that this is isocyanide. So benzene carbylamine. Next, this is main chain in that nitrogen with that this methyl is connected. So how to write? Don't write 1 and 1, this is not carbon, so we'll write n comma n dimethyl aniline. Here you can see this is carboxylic acid derivative, so this is benzene carboxamide or benzamide. Clear? Similarly here this is benzene carbonyl chloride or benzoyl chloride. So whenever O is coming means that carbon all valency, means hydrogen is not there, this carbon. So this is benzoyl chloride. Similarly here 1 phenyl. So here that this is the main chain. So this one is 1 phenyl ethane, 1 means this is ketone. Similarly this is phenol. So phenol is also called carbolic acid. So phenol is also called carbolic acid. This is orthocresol if methyl group is here, meta if methyl group is here, paracresol. 2OH, so this is called catechol, resorcinol, quinol, and this is called quinone. Clear? Next, while writing all those prefix of alkyl group, for methyl we can write in short form Me, for ethyl we can write Et, for propyl we can write Pr, for butyl we can write Bu. This is benzene derivatives of aromatic compound anthracene, phenanthrene. This is azulene. Azulene is also aromatic compound. You can see total 10 pi electron conjugated, double bond, single bond, 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 double bond, means periphery in conjugation, hence it is cyclic, planar and aromatic. In writing IUPAC naming of organic compound with functional group, this carbon is alpha carbon, this is beta, this is gamma, this is delta. So we can write instead of 3 hydroxy, we can write 2 beta hydroxy pentanoic acid. Similarly, this system is called vinyl system. If carbon is here sp2, if carbon is sp3, this is called allyl system. This is benzyl system. Here you can see 2 hydrogen is there, then it is benzyl. If 1 hydrogen is there, remaining 2 is connected with oxygen or something whatsoever, then it is called benzyl. If all 3 hydrogen is removed, benzo. Clear? Next, this is called your benzyl, whereas this one is called phenyl. This is, you can see, benzoyl. So here you can see almost no means all hydrogen is removed, so O word is coming. So benzoyl. This is acetyl group. So this all those in IUPAC is required. If it is required, you can use this one while writing its IUPAC naming. Last, some just practice we will do. So here you can see that this one is the carboxylic acid. So this is the our main chain. So in this main chain so here you can see that instead of this we can do like this, this way. So here this is the main chain. So 1 2 3, so it is coming 2 hydroxy and methyl. So 2 hydroxy methyl propanoic acid. Okay, little bit interesting, that's why I consider in examples. Here you can see this is the our main chain, longest carbon chain including double bond. So here that 1 2 first double bond will give lowest number, then after 3 4 5 6. So at 3 this carbon 3 degree carbon, so this is tort. So we can write what 3, and then after if I'm writing branch of having branch, then it having 1 comma 1 dash. So 1 dash 1 dash dimethyl ethyl, where at 3, and at 6 what is there, isopropyl, or we can write 1 methyl ethyl cyclohexane. Or another way also we can write, this one is isopropyl, whereas this one is tort. So remember, third, secondary, this all those not considered in alphabetical, but iso, neo are considered in alphabetical. So this is 6 isopropyl and 3 tert butyl, and then after cyclohex 1 next, these all those naming, like here you can see this is called tropone, this is furane, this is thiophene, this is pyridine. Some examples of that NCERT I included, and here we completed all those concepts, all those rules which is given by IUPAC, and hence here our that included included all those examples also which having little bit twist and turn. We completed that synopsis of IUPAC. Thank you very much.